In this section, we're going to look at the chain rule. So what the chain rule is if you have a function within a function, so a composite function, you can find the derivative by taking the derivative of the outside and then the inside. Now you might note that it's the function of the outside, however you keep the inside the same. Now, if that doesn't make a lot of sense to you, what a lot of people will do is they do it as a substitution, where they say u is a function of x, so whatever's inside, and then you take the derivative of the whole thing. So use the chain rule to find the derivative of all of that. Now, I'm going to use the second one because that's the easiest one to work with. So you let u equal to x cubed plus 2x squared minus x to the power of negative 2. Then you find the derivative of that, which is 3x squared plus 4x plus 2x to the power of negative 3. Then, because we let u equal to all of the stuff inside, y isn't equal to u to the power of negative 7. So then dy du, so we're differentiating in terms of u, is negative 7 u to the power of negative 8. Putting all of that together, we get dy dx. So then equal to dy du, which is negative 7 u to the power of negative 8, times du dx, which is 3x squared plus 4x plus 2 x to the power of negative 3. Now we have it in terms of x, not u, so then we have to substitute u back in. So then we get negative 7. I'm going to write all of this in the front. Then we have u to the power of negative 8. Because it's negative, it goes on the bottom. And then we just write whatever u was, which was x cubed plus 2x squared minus x to the power of negative 2 to the power of 8. You can change all the different things with fractions if you like. I'm just going to leave it at that. Use the chain rule to find the derivative of y equals to cos squared e to the power of x and evaluate the derivative when x is equal to 0. So this time the function inside is e to the power of x. So then du dx is equal to e to the power of x. So that's nice and simple. Y is equal to cos squared x. So then the y du would then be us letting cos of x to be another function. So we take the power down. So 2 cos x times the derivative of what is inside. If you don't know what I mean, maybe if I write it this way, it will help you. So that's your function inside. This is the function outside with the squared. So when you take the derivative of a squared, you take the 2 down, you get cos x, and then you take the derivative of the inside, which is sine of x. So then the y dx is the y du. That's cos u, by the way. So 2 cos u sine u times du dx, which is e to the power of x. Substitute e to the power of x back in, so we get 2 e to the power of x cos of e to the power of x sine of e to the power of x. Now we also have to evaluate the derivative when x is equal to 0, so let's sub in x equals to 0. It's also not y du, that's dx. Anyway, so dy dx equal to 2 e to the power of 0 cos e to the power 0 sine e to the power 0. Now anything to the power 0 is 1, so then we get 2 cos 1 sine 1. Putting that in the calculator, we get 0.9093. So for the function with the rule y equals x minus 1 to the power 2 over 3, find dy dx. So simply use the chain rule. So let u equal to x minus 1, then y would be equal to u to the power 2 on 3. dy du is 2/3 times u to the power of negative 1/3, and then du dx is 4, get a 1. So therefore, dy dx is equal to 2/3 times u, which is x minus 1, to the power of negative 1/3. B. Equations of the tangents at 2, 1, and 0, 1. So x equals to 2, dy dx is equal to 2/3 times 2 minus 1, negative 1/3. Because that gives you 1 inside, this just becomes 2/3. So then substituting it back into the linear formula, we get y minus y1, which is 1, equals to the gradient, x minus x1. So same thing with 0, 1. dy dx is equal to 2/3 times negative 1 to the power negative 1 on 3. Now, because it's a cube root, it's going to be negative 1. So then we get negative 2 over 3. So then same thing. So y minus 1 equals to negative 2/3 this time, x minus 0. So then we get negative 2 over 3, x plus 1. Then C, find the coordinate when these two tangents intersect. Well, you can put in the calculator from here on as a set of simultaneous equations. So we have y equals to 2/3 of x minus 1/3. Y equals negative 2/3 of x plus 1. Put in the simultaneous equation, you'll get x equals to 1/3, and then y equals to 1.